Um, okay, well, hello everyone and welcome. At least I can speak for my group. We're missing the CER community at conferences this summer. So we're hoping that we can supplement that with some conversation about research. So to start, let me introduce our discussants. We have Stacey Lowery Bretz, Distinguished Professor of Chemistry and Biochemistry at Miami University, and Mike Klymkowsky, Professor of Biology at UC Boulder. Both have done a substantial amount of work in developing concept inventories. So thank you all so much for being willing to share with us what you all have learned. To facilitate this, we've crowdsourced some questions from you all a while back, and those questions center around three themes: designing concept inventories, using concept inventories for ed research, using them for teaching. So what we're going to do is have three chunks with those questions. To try and get the most from our discussants, we're going to give them each 2 minutes to respond to the questions and to each other, and then a little bit of time for exchange between them. And I'm going to do my best to keep us on track for time. So I have this little sign that says you have 30 seconds to wrap up your response. But that being said, we will feel out when conversations need to continue, and if we don't make it through all the questions, we don't make it through all the questions. I'm very confident that their responses are going to prompt even more new questions from you all. So to get those questions, you can write them in the chat, and either Vicente or I will try to acknowledge that we see your question, or you can wait till the breaks in between our themes, and if you raise your hand, we will try and give you voice to ask your question in person. At the end, I think there's a possibility that not everyone will be able to get their questions asked and answered or discussed, and so what we'll do is try to keep track of all the questions and have an ongoing discussion on Twitter for those who want to participate about this, to the extent that you would like to participate. Does that sound okay? All right.
Alina, I just wanted to mention that the webinar is being taped, and it will be available for everybody to view afterwards in a YouTube channel where all the webinars are posted.
Yes. Great. So what I'm going to do is alternate between Mike and Stacey for who responds first to the question, and I'll just give you a heads up. And the first question is so lovely. What is a concept inventory and what is not a concept inventory, and what does it measure? And we'll have you start us off, Stacey.
Okay. So I don't think there's a universally agreed upon answer to those questions. There is a Wikipedia entry for concept inventory. I've read it and I don't agree with most of it, but that's all right. So I guess I would break my thoughts about what is a concept inventory and what it's not into two large categories. There are some surface characteristics that I think people look for when they look at the instrument or the tool and expect to be there. And then there's some underlying structure to it. On the surface, there are often multiple choice items, although they don't have to be. Most commonly, the distractors represent student thinking. That is, they're not questions written with a really long technical answer with all the key vocabulary or jargon that an expert would use. Sometimes they come as single items, sometimes they come as paired or tiered items, where the second one is asking a student why they chose an answer to a previous question. There are some that are focused across a wide number of concepts. There are some that say they're focused on just one piece of an idea. Sometimes they include some indication of a student's confidence in that response. Those can range from ordinal options like Likert indications, which in my opinion are not very good, to ratio kinds of data, options like a slider bar, continuous slider bar. Those are some of the surface features I think people expect to see. Underlying the characteristics and what it measures is much more difficult to, to actually pin down. I think most people would agree that the data that comes from students' responses to a concept inventory tell us something about the accuracy of students' thinking and reasoning within a very narrow specified set of content area. I think fewer people would actually agree that it tells us how much a student knows about a concept. The distinction there between accuracy and how much often lies in the methods that are used to develop them, because concept inventories are not meant to say this is everything that's known about a particular area. So depending on if you design from top down or bottom up in creating it, you lean more towards one about how much of it measures.
Mike, can you speak to that a little bit?
Sure. So I would basically agree. What I would sort of like to stress is the idea that a concept inventory is, in general, I mean, the traditional ones are multiple choice, just to make them easier to analyze. But their research, to me, when we built one, they're research-based instruments. And one of the key components is that they're targeted to sort of overarching concepts, things that you use to build an answer. And probably the key thing that separates them from a typical multiple choice test is that the distractors are research-based, in the sense that they are ideas that students actually hold and use or sort of rely on. They may not even think about them. So, I mean, this is a generic problem with multiple choice tests. If you don't find the distractors distracting, then the test gives an excessively positive response, because almost all students have heard the right answer. And if the wrong answers are not things that they think, then it doesn't mean anything. And so to me, a concept inventory is something designed, it's essentially a low resolution instrument. I like to think about, assessments as in terms of resolution, and it gives the course instructor, course designer, a heads up on ideas that are difficult or sort of conflated with other ideas. It's really not meant, you've already done the research to figure out how sort of what standard students say. You're trying to see, what is your class, where is your class coming from? And so that, to me, that the key is that it's a research-based instrument, that the distractors are based on what students actually think, as opposed to, here you are writing a multiple choice test and you got to find 3 wrong answers so you can distract, but they may or may not be distracting. So that would be what does it measure? It's not clear what it measures. I think you have to go back in. So I would argue, I would argue pretty strongly that they're not good for pre-post sort of measures of learning because they're too low resolution. Okay? So they give you a heads up about problems and that you should consider when you're designing your course, to me.
So to that end, what are some of the major challenges in designing good concept inventories?
Well, I would say the question is, how do you build a question that is not sort of reflexive, that causes people to have to use ideas to answer it, right? So, you're getting around recognition and remembering answers to, here's a general, so this comes down to the idea, well, what is a concept, right? So I was thinking about this a fair amount, and to me, like a concept is a general rule that you use to make sense of specific scenario. And in the sciences, most concepts are not straightforward or commonsensical, right? They're built, to be a scientific concept, it's sort of like you went through this pain and suffering to come to this general understanding that this is the way the world works, right? And you can apply this kind of way the world works to many situations. How does a protein, so this, I know this is CER, but I'm a molecular biologist. how does a protein recognize a target on DNA? Well, it's through intermolecular interactions, its shapes, and essentially everything in biology is like molecules interacting through various shapes in various feedback networks. So the concept that, everything occurs by a sort of molecular mechanism is critical, and then you apply it, right? To me, that's sort of the idea. What are the underlying concepts? How do you write those questions? And they can be hard to write because you can't really, how much detail do you present? If you're trained to be an instructor, you're used to presenting so much detail that the answer just reflects the fact that students are paying attention, as opposed to, are they capable of solving a complex problem? And I'll stop there.
Stacey, what have been some of the challenges you've encountered?
So when I think about what are the challenges in designing a good concept inventory, that word good really smacks me in the face as somebody who's a analytical chemist much earlier in her life. Yeah. Concept inventories are an opportunity to surface what is connected in the student's mind, what's the nature of that connection or relationship, knowing full well that they are missing connections, they have inaccurate connections, they have things connected that are B, but the nature of the relationship's not accurate in their mind. So when I think about how we're going to measure something with a good concept inventory, there's a big disconnect between what's a good measure from a scientist with precision and accuracy. They don't map with precision onto validity and reliability. And one of the things that I really worry about in our field right now is the fascination of some people with more and more sophisticated psychometric techniques trying to establish that something's good when the underlying assumptions of those psychometrics are really orthogonally opposed to what a concept inventory is supposed to do in the first place. So let me give a couple examples there. A lot of psychometrics presume that something is unidimensional, or it's made up of subscales or scales, which both of those then presume that things should be correlated and connected. And so if we bring measurement techniques to bear on a data set where the assumption is we're looking for what's well connected or well correlated, and the whole point of the instrument is to surface ideas that are not well connected or the connection is not accurately characterized, that's really problematic. And so then I see things with people throwing items out to make the psychometrics better. So we have this training as scientists about how to get a good measure it more times, create more of the same items with the same distractors. You can raise your psychometrics that way, but that's not good from the point of developing a good measure. So I think it's really challenging to create a good measure and use our training as scientists about what counts as good measurement. That's a problem. I don't have a good answer for it, but I'm not excited about the direction that some of the literature is headed, where we're trying to just be more and more fancy psychometricians to make that happen, because I think that's actually not the right way to go. There are also challenges with content validity from an expert point of view. We've done, many of my students are on this call, so I want to make sure I say we. We've done many interviews with faculty after we've drafted the instrument and we run through with them, take a look at this for us, and they're like, why are you even asking that? Students won't know that. I've never taught them that. Like, faculty don't know what students' prior knowledge is, and that's really problematic. Physical chemists have argued with us about the definition of an orbital. Xylene's on this call. She'll tell you that when we get that feedback back and they don't agree on what an orbital is, how are we supposed to explore what students think an orbital is? So establishing reliability of the data when we're going to measure multiple times and say that there's consistency in the students' thinking is hugely problematic when it intersects with a tool where the students' thinking is not well characterized to begin with, and then it's changing because they're learning. And so this idea of reliability or consistency of measures for me is really challenging for establishing evidence of a good concept inventory.
And that raises a number of interesting issues for me. I'm responding to that in a way like, the idea, to me, an orbital is a quantum mechanical concept, right? And so in biology, there's a level, this idea of resolution to me is really important. we are, and you realize that in biology, every organism is completely different. I mean, there are these common features, then you go into the weeds and you see all these little differences. You know, there's a classic example of a mechanism that's very well defined in the fruit fly Drosophila. It's only used in that class of insects. So you sit there and say, well, how do I get students to understand these broad underlying, right? And getting down to these, do you get these universal ideas? I'm assuming that if I want you to memorize, you know, how the bicoid system works in a fruit fly, you can do that. But can you look at a new system and apply these underlying ideas and make plausible arguments about how something may or may not work? And to me, this is really the core question, right? What are these underlying concepts that you use over and over and over again, essentially universally, but that students are very rarely taught? And because it's so much easier in the practical weird world of academia to teach people to, you know, to learn factoids, memorize amino acid names, you know, blah, blah, blah. And as opposed to saying, okay, make me a model of how this feedback network works. You know, how do I get a molecular switch? How do I build a molecular clock? You know, how do I do that? Okay. And so that's an interesting, and underlying, pulling out what students don't get can be really tricky, right? I mean, work I've done with Melanie Cooper, or her group did, and included me, was, you know, realizing that at the end of the day, students are coming out of 4 semesters of chemistry not knowing what a hydrogen bond is, and not being able to distinguish it from a covalent bond involving a hydrogen. You know, so you're thinking about, well, what is it, how do I focus my instruction, course design, on these core concepts that allow a student to do something new, as opposed to drilling them on something that I've presented, right? And that's a really sort of central distinction between a concept inventory, in my mind, and, you know, a test. You know, for example, you know, with Kathy Garvin-Doxis, we use the BCI, the Biology Concept Inventory, to recognize students are just lost when it comes to stochastic random behaviors. And yet they drive a huge amount of biology, because now we can see which genes are expressed in individual cells, and there's a lot of stochastic differences, even between cells that are apparently identical. So you now have your eyes opened as an instructor to ideas that are difficult for students to get and apply. So I think that the value of concept inventories is to sort of understand what students are having a hard time getting. And that's why it's so critical that their construction is based on what students actually think, rather than what instructors imagine students think.
I'm so glad you brought that up. And Stacey, that you brought up these assumptions that underpin the development. One of the questions that was asked is that the CER community is increasingly adopting a resources-based view of cognition, which assumes that context plays a role in which resources are activated. And I'm wondering if you all can speak to what extent do concept inventories align with this framework?
Yeah, so I think that's a really intriguing theoretical lens to bring to the work. It stands in stark contrast to where concept inventories got some of their initial beginnings, at least in chemistry, with David Tregis's work, where faculty were going to identify propositional knowledge statements and create a concept map that articulated all those out as though the students had to fit into that framework, right? It's a very different approach to it. Certainly the clinical interviews or the think aloud interviews that are often conducted, as Mike was saying, to generate the research-based distractors, those interviews elicit students' ideas in the context of something. In our group, we use multiple representations to see if we can get them to talk differently about one set of experiences than another, but it's all within the context of one interview. Different contexts certainly evoke different resources. And to go back to the comment I was making before, that's going to make it super hard to examine reliability and consistency among students' responses. Every clinical interview has boundary conditions, to borrow another phrase from our experimental work, right? So in the one we most recently, one of the ones we most recently did on enthalpy and entropy, looking in dissolving at precipitation with Tim Abel, we only looked at aqueous solutions, and we only looked at ionic solutes. We didn't look at non-aqueous, we didn't look at molecular solutes, we didn't go after KSP. There's lots of things we didn't do in that context. Having said all that, my group hasn't, for example, set up dueling concept inventories where we try to create two completely different interview contexts to test this resources framework to see if, even though they have the same underlying conceptual underpinnings, do we end up with different distractors and different kinds of items because we elicited them with different contexts? We haven't done that experimentally yet. That hasn't quite felt fair to me as a research advisor to pit two grad students against each other and say, go, see who comes up with the better data and the better instrument.
No, that makes, I mean, that makes sense to me. I think I'm not, you know, we built one concept inventory and we haven't been doing much of that. We've been thinking about what people are doing, and part of what's emerging is looking at, through various activities inside classrooms, what ideas students can activate, what ideas that they ignore, what ideas are relevant. You know, so you have to define sort of, well, what ideas are relevant in this context, which ones do they activate, which ones do they don't activate, you know, which ones do they take seriously. This, you know, this sort of came back home to me when I was thinking about threshold responses in biological systems, which are always nonlinear. And you sit there and say, well, where are they coming from? And you realize, oh, I haven't talked about, you know, saturating a response. I haven't talked about, you know, the initial turning on of a response in a macromolecular system. And to me, it comes back to that idea, oh, I know what I should be teaching. You know, the value is, oh, I didn't think about this. I didn't present this to the student. So of course they can't activate it. You know, you know, so to me, it always comes back down to course design and presentation. What am I presenting the student with enough of the relevant ideas that they can actually do this problem? Or am I presenting them with ideas that allow them to solve the problem heuristically? So they don't understand why they know that they can recognize the right answer, but they don't know why. And I want them to build a plausible answer and not worry about the right answer. And so I'm coming back to, you know, I'm always thinking about, well, how do I learn what's going on in students' heads? And that's where, that's the driver for what we've been doing, is sort of like, how do I understand what's missing from my instruction in order to get people to really get this idea, right? We do this a lot with entropic, you know, factors, in the sense that most, you know, proteins fold primarily because they're driven by entropy. Most students, you know, a membrane forms is an entropic process. You know, do they get that, right? Do they get the spontaneity of things? Do they understand the noise inherent in biological systems? So that, again, it's really trying to understand what's missing from my instruction, right? To help them be able to say, oh, that's an example of this. This is, you know, here's this common conceptual thing. I can apply it everywhere, as opposed to distracting them with too much detail. That's you know, sort of idiosyncratic. And this is, you know, chemistry is more limited. There are only 92 naturally occurring, you know, elements, you know, but there are millions of species, okay? And they have the most weirdest adaptations. So you can't, you know, it's very easy to fall into this specifics when you should be talking generalities.
I feel like
So
that
I'm
might have
gonna-
been a little diss at chemistry. I don't know if I should engage to point out the difference between elements and compounds, but I'll just.
No, I get that. There are a lot of compounds. I get that there are a lot of compounds. I've been schooled.
Oh, I have
I'm
no
gonna
doubt.
pause you all there, and we're gonna take a few minutes to answer questions. So audience, go ahead and raise your hand and we can unmute you if you wanna ask in real life, or I can just pose the ones that are in the chat. But come on, brave ones. Okay.
There we go. Oh, the bravest of them all.
Am I ready?
We are.
All right. So this is not as well formed as I'd like it to be, but I am increasingly becoming aware that in some of our assessments and all kinds of assessments, how do you differentiate or what role is the purpose of the assessment, how you're going to use the data? How does that play into our understanding of what the assessment is? Because even in the conversation that I've been hearing so far, I've been hearing some talk about like, oh, the assessment is this, and yet I'm also hearing it's nothing without this purpose. And so I'd like you to talk a little bit about how those two things play together, the way we use the data and the data that we collect.
Yeah, so I think Mike's comment about what's missing from my teaching really resonates with me. I certainly would use these in a teaching context to get some sense of what my students' prior knowledge is, not just for me, but also for them, right? Like if you're teaching students and they're about to draw on prior knowledge, either because you're in Organic 2 and you expect them to know something from Organic 1, or you're teaching seniors and you need them to, you know, surface some prior knowledge they should have mastered from their freshman year or whatever, it can be very informative to have those items where they've gotten past the, oh yeah, here's the memorized answer, right? But to, here's how I really think about it, right? Like to pick on a different discipline, I won't pick on molecular biology, I'll pick on physics. I know the answer to the forced concept inventory question about the big truck and the little car. I know what that answer is, but I also know how I really think about it. And those laws of my everyday life. And so they can, when you're designing the items, you don't, at least in our group, we want to get past sort of these rote memorization things. You'll see there's almost no mathematics in any of the tools that we've designed because students learn how to manipulate those symbols. There's lots of people on this webinar, when I look in the participant panel, who've done extensive research on that idea. So we don't even try to include those because that's just students masquerading with the symbols. We want to get at how they reason through a context and how they describe that context, because that underlying mental model of what they think the molecules are doing or the structure of those molecules and how it connects to the function of those is really the more important idea that we want to surface as to deal with that prior knowledge before instruction's happening or while instruction's happening in a new course.
Yeah, I would say you can make two in the real, whatever the real world is at the moment, which I'm quickly losing touch with. But nevertheless, concept inventories have been used even originally, particularly with the work of Hake, to say, oh, this way of teaching is better than that way of teaching. Okay? And they're used sort of a summative, justification for what you're doing in the classroom. That seems to me to be the wrong emphasis. It's like they're not measures of success. They're too low resolution to be good measures of success, particularly in physics where people are trying to get to the 10th decimal place, or further, right? It's like, I'm surprised that people are satisfied with a low resolution instrument. To me, they're a driver for rethinking the curriculum so that it's more effective. And that means, and part of where you're coming from here in the sense of is, I got to think of my audience. What is my audience? What are my students bringing to the classroom? What can they do? What can't they do? What ideas do they fall down on? So in biology, things want to do things, right? That's a very common problem. Well, you're trying to get people to understand how sort of mechanistic processes can produce meaningful responses. And so to me, the real value of concept tests are not summative evaluations of the effectiveness of a particular class. They are to provide insights about what a population of students needs, what ideas need to be addressed for that population of students. Where do they need to be brought? How do I get them to practice, to consider, to reflect on the ideas that they bring? And am I presenting them effectively? So I think So I disagree with using them as an evaluation of outcome because I think they're too low resolution and it's too easy to teach to them, okay? Because particularly if they're a multiple choice instrument, there's only one damn answer. And, you know, so you can explain why the wrong ones are wrong, sort of, but, you know, you're sort of training them to do that. And it's a false metric for success.
So from you all have sort of touched on this, but what are some of the major benefits of using these concept inventories once they're developed in educational research?
Oh, I think I'll take this one to start because I think they allow you to focus on ideas, right? And I think that, you know, so, I mean, there are various tools you could use if you're not like a full-time educational researcher, is that taking responses from previous exams, reflecting back, but you can sort of think about, here are ideas. They force you to think about underlying ideas, and then you can use them to restructure, you know, what am I emphasizing what's right? Am I emphasizing what's wrong, right? And so to me, that idea of using them, and if you want to use a pre-existing one, the good thing is to say, here, I've got students coming into class. Where are they in this? Where are they? Okay. Have they already learned the right answers for certain ones? Or are they still displaying, you know, the sort of confusions or misapplication of ideas? And that's why the distractors are so critical, right? If they don't reflect what your population thinks or have been introduced to previously, they don't tell you anything. So the better your distractors are, the more informative it is for you in your classroom.
Yeah, so I will just add to that that we haven't actually used the inventories that we develop in a subsequent study as a tool, right? So I mentioned I was once an analytical chemist, so analytical chemists get excited by making measurements and show that they work with a few system of interests, and then they turn them loose to the rest of the world, but then we go back to making more measurements. In some ways, that's how I run our research group, but I can imagine people using them as in a subsequent research project where they want to sample for convergent or use it for convergent or divergent validity. They might use it to sample students who they want to conduct clinical interviews with. They might want to use it to assign students to different interventions, things like that. Some way that they're characterizing the prior knowledge of the people that they're about to do a research study on.
Okay. What are some of the major challenges or considerations when using concept inventories in educational research? And that's paired with what are some of the common mistakes you all have seen?
Yeah, so I answered this more about what are some of the more common mistakes rather than challenges. That's where my mindset goes to. So first of all, just some language. People often talk about instruments being valid or reliable. That's not accurate. It's the data that are either valid or reliable or not. Validity and reliability of data is not, once it's done, it's pronounced forever. Ominous dominus. That's not the case. They need to be reestablished with each study that you do. You can't just presume that because it was used with, you know, first semester pre-meds at such and such university that it's good for first semester pre-meds at your university. I get a lot of requests to share our concept inventories from, at last I counted, it was like 30 different countries around the world, and people want to translate them, and that's great. But there's all kinds of issues with translating them into a language other than the English in which the clinical interviews were even conducted in the first place, let alone the items being written. People have concerns about distractors where only 5 to 10% of the students pick one. And then they say, is that really a valid distractor? But you got to look at the math. Some people only want distractors where it's guessing plus 10%. You can't have 4 responses and have them all be guessing plus 10%. That's not going to work. And I think the other mistake I've seen that comes to mind has to deal with item difficulty and discrimination related to that point. So traditional measurement would suggest that you delete items that are below 0.2 or above 0.8 on a difficulty scale because they're either too easy or too hard. But I would say that's not the case for a concept inventory, because those are both very interesting data points. The very difficult items, right, the ones below 0.2, remember difficulty is that inverse scale. It tells you the fraction that got it correct. The ones that are below 0.2, those are an indicator of what are the most challenging, persistent ideas, even for your what could be for some of your brightest students, depending on the discrimination. So those are really worth maintaining. Likewise, the items that are above 0.8 on the difficulty scale, or quote unquote super easy, a lot of times the inclination is to get rid of those because they're too easy. They don't tell you anything. I think there's a little bit of strategy involved there with some of our colleagues who may be skeptical that their students hold any misconceptions or would do just fine on these instruments. I think it's good to have one or two items that are particularly easy on an inventory, because it establishes some sort of baseline about, look, the students do know this. They do understand this. It's all these other things they don't. If you only have hard items, or only items between that 0.2 and the 0.8, below the 0.8, you run the risk of people looking at your instrument and going, well, it's just too hard. You asked all the hardest questions. Of course they didn't do well on that.
Right, and that comes from the idea that scoring well on a concept inventory says that you taught them.
Right.
And so I mean, so the tricky, and I would say that an interesting, to go off that, you know, if there are three really good distractors, well, you know, it depends on which one is the most attractive. You built them and so that they're really seductive, right? So if you're really good, you may only find one good distractor. If you pulled that one out, which is something rarely done, you know, give it 5 times, but with different sets of distractors, you might find that they believe all 3 distractors are correct, right? And, you know, rarely are students asked to explain why distractors are wrong. So if you wanted to use them in a different way, I mean, I've had this discussion with my closest colleagues, and I love the idea of saying, okay, explain to me why the wrong answers are wrong, independently of what, because I have this philosophy basically that wrong answers are wrong basically for one really good underlying reason, and right answers are correct for 47,000 reasons. And so if you can explain, you know, that's a good way to use them. Tell me why the wrong answers are wrong. And so that's not the standard way, because it's not a simple multiple choice type of analysis. But that way of thinking about, well, what do I learn from various kinds of wrong answers? I learn more from wrong answers than I do from right ones, basically. Right? I mean, so that, I guess that would be they're not meant to be used as standard summative assessments.
Right.
Right? I mean, it all comes back down to what are they for, right? They're not for confirming your belief that you did a good job teaching this semester. They are for understanding what students are thinking.
So,
and the only reason, well, let me say one more thing. The only reason the FCI really, you know, got traction is because everybody thought that they were learning physics. Okay, I mean, you know, so when Phil Sadler was doing, you know, his, you know, private universe videos, that's the shock of it. Oh, here these people are getting A's in a physics test and they can't explain, you know, what they should be able to explain.
So how as a field do we deal with the tendency of researchers to want to omit or change questions in existing instruments in their use?
I have a short answer, which is it all depends what you're using it for, right? If it's a broad instrument and you want to target, you know, so like in the BCI, there's a set of questions on genetics. Now, if you want to talk about how genes behave, then you can pull those questions out. And I wouldn't be upset with that. You know, it's not meant to be an overarching confirmation of education, of, you know, student understanding. It's meant to be a tool to target, you know, to understand what students think about something.
Yeah, I think it's fine if you want to pull them out as a teacher. and you're only interested in a subset of them, or if only some piece of it overlaps with the research question that you're pursuing, that's fine. I think the things that bother me are when researchers pull items out because they're not, quote unquote, functioning well. Because the way I would describe that is that's a preference for good psychometrics over honoring the students' voices, right? And so when you pull things out because you want to improve the underlying latent factor structure, or you want to improve the fit indices for a factor analysis or anything like that, then what you're saying is I'm valuing things that are well correlated, as I alluded to at the beginning of this. And if that's what you're doing, you got to be honest about it, but you're losing the students' voices and important ideas along the way. And different research projects have different goals, but the goal of creating concept inventories is to, in some ways, honor the students' voices and ideas, not to develop the best psychometrically functioning instrument that we can by taking out items that are problematic because they're actually detecting that really confusing signal from the students' thinking.
So y'all's concise answers leave some more space for questions. So I'm gonna pause. David had a question in the previous session that I wasn't able to field. So David, I have you available to talk.
Okay. Yeah, this is kind of a follow-up on Valerie's question. First, I wanted to mention, Mike, in respect to something like the FCI, it can be shockingly difficult to teach to the test. I have many, many times, out of exasperation or desperation, actually tried to, gone over certain questions in class and then been amazed when I see the post-test exam and see how they answered the FCI, and see that the things we've done 1,000 times in class, they still persist in picking standard distractors. It is shocking and amazing.
Right.
But my key question really is, to what extent do concept inventories, do they or should they map onto the learning goals of typical instructors of the introductory courses? Is that something that is a useful goal? Is that something that is a practical goal? Or in your mind, both of you, do the inventories serve a completely different purpose?
So I think this is a fabulous question, in the sense that I think if you're frustrated that you can't get students to understand something, it's because you're not approaching it correctly, and that you need a different approach. And that's the message that should come back, right? Like, I'm not going to bludgeon them into submission so that they, they'll repeat the answer. I think the second part of your question is what are the appropriate goals of a particular course, right? And so then this becomes an academic, political. This is a very interesting problem, which is many instructors and professors normally are oblivious, but instructors are paying attention to what the rest of the faculty or the department thinks they should cover, as opposed to what students should understand or need to understand to go forward. And to me, a well-designed concept inventory leads to a rethinking of the course goals, right? And to lead to a more effective understanding, such that people are not swallowing X-ray lamps into their lungs to try to cure a virus, okay? So my goal in physics is to suppress this kind of behavior to begin with, right? So I believe the curriculum needs to always be itself the subject of reflection. And so if an idea is hard to understand, it may be that it's not being presented in a way that's understandable by the majority of the people taking the course. So you're not teaching it. If they're not learning it, you're not teaching it. And so this is this confusion between online learning and online teaching, which before this began, people were talking about, oh, we're doing online learning. Well, you don't know that. You're doing online teaching. So the concept map, concept inventory is designed to get you to take seriously what it is students are thinking. And I think it's back to what Stacey was saying. you're valuing, you're honoring the student and realizing that they have an idea and you need to figure out a strategy to get them to a eureka moment, one way or the other.
Yeah, what I could say is that when we have weekly group meetings, so we run them jointly with Ellen Yezierski at Miami, we have for years. And one of my graduate students or postdoc will get up there and share some interview data or data from the concept inventory. I'm always of this very schizophrenic reaction to it. The researcher in me is like, that's fabulous data. Yes, that's great. We can publish that. And the teacher in me is horrified because I hear new ideas that I've been teaching for 25 years. And that's the first time I've heard that. Why? How did I not know the students didn't think about it that way? What experiences am I gonna build into the course for students to share those ideas and work through them? And to Mike's point, it's always leading to a reevaluation of the curriculum. I have to get rid of this and get rid of that because it's going to take time to go through these ideas and really honor their thinking and help them deconstruct, reconstruct, share, negotiate, rebuild new models to go forward with.
Right. I mean, if I have it, so I have a sort of allergic reaction to the term active learning because one, I don't think there's any other kind of learning, but two, in much of the active learning community, there's really no reflection about how to change the curriculum to be more effective. It's mainly changing the style of presentation. And I think the value of concept inventory instruments is to force you to think about what the students are coming away with. And I think you got to be prepared to change the way you present the material presented, all that becomes critical, right? Because otherwise you have this sort of legacy of professors talking to people who want to become professors, which is not what most institutions are being supported by. Right? The people who are paying for the institution want an education. They don't want to become a professor necessarily.
So we have time for one more question from the audience. Jack, I have you permitted to talk.
Yeah, so Stacey, I just wanted to say I appreciate you noting the validity and reliability as being aspects of data and not these tools that all of us are producing. And that this is an ongoing process, that when people are using, a concept inventory or any tool in different types of populations, that they should be looking for evidence to support that data. So I was wondering if you could just comment on sort of what that minimum level of validity and reliability is that you would want someone to show for your instrument or anybody else's, acknowledging that we also shouldn't be over-interpreting what an instrument developer's design has. And certainly with something like the forced concept inventory, it's been interpreted and processed in ways that was never intended by the developers. So thank you.
Yeah, sure. Those are all really, really good questions. I'll try to give a brief answer as I can, but still honor them all. I think validity there are multiple kinds of validity, and that's the much easier one to address, the validity of the data, right? The face validity is super easy to address. The content validity, the construct validity, all of those are easy to do. They can be time consuming to do, but I think we can all agree when those have been met. For me, the reliability is the much harder one to get at, right? So if we take consistency as one synonym or one proxy for reliability, that's just much harder to do because when you start to think about what are the different ways you can measure reliability, test, retest fails because the students have changed in the meantime. Split forms is not easy to do because these items are not iterative the way we can generate multiple items for multiple choice items for a test that we're all trained to do as students. So you can do, those are much harder to do. I actually don't know. This is a standard I myself have been really struggling with. And if you ask my current students, I don't have a good answer for this. I've yet to, the more I've thought about it, the more deeply I think about it, I don't actually think we have any good evidence of reliability for data from concept inventories. And that's horrifying to me as somebody who's built a bunch of them, published a bunch of them, have more in the pipeline. if somebody was to look at the progression of the papers that my groups write, we get more and more and more hesitant to make claims about reliability for data. The statistical measures, no matter which Greek letter you pick, all have underlying assumptions about correlations and fit, structure, et cetera. And as I've said a couple different times tonight, I don't think that's a good map onto the way that we develop concept inventories. There's not this assumption of inherent structure and correlation and connectivity amongst students' thinkings, because distractor B on one item and distractor B on the other are not necessarily even of the same underlying ideas. The items are developed to give voice to the ideas in the interviews, but doesn't have to be this construction that you're testing the same ideas on every item. And so for me, the issue of reliability is super problematic.
I don't have that much more to answer, because it all comes down to what you're using it for. If you're using it to drive course redesign, then of course you're not going to use the same instrument pre-post, because you've just taught them, right? And it's, again, I think it depends on what you're using it for. If you're trying to justify some strategy that you say, oh, this worked, then I think you have to go to a higher resolution instrument. You can't use the same instrument for both ones. You need to go higher up. You need to ask a different set of questions, right?
That's so great, actually, because we're transitioning into thinking about concept inventories for teaching. So I'm wondering if you can follow up on that with what you think of as the major benefits of concept inventories for teaching.
Again, so it gives you a heads up on ideas that are problematic, but at the end of the day, you can, and we've done, looking across the curriculum in various ways, and you see that there's no general improvement in many items. And you realize, oh, here's a problem that we have to think about. I mean, a classic one in biology is a phenomenon called haploinsufficiency, which having one functional copy of a gene is not enough. So you get a dominant effect. The mutation is, the allele is dominant. Well, the number of students who can get to the end of a molecular biology curriculum and still not understand that genes are objects, that there are only so many polymerase molecules that can run down a gene per unit time, that the number of genes you have determines how much product you can make, all of a sudden you say, oh, I get it. This is an idea that I have to think. I have to come back and think quantitatively. I have to present material in a more sort of molecular, mechanistic, model-driven way. So to me, that's the key about these. Do you use a concept test or an inventory to get insights that you can now introduce into your curriculum? And then you can resolve whether people have learned them by asking multiple questions that rely on those ideas.
Yeah, so I think we've talked a lot about the benefit to the teacher. So I think what I could add at this point in our conversation tonight is, what's the benefit to the student? So this goes back to, in some ways, the question Jack asked about validity. The face validity is so important to the student. When you give them one of these concept inventory questions, and whether how you administer it is not important, on paper or as a clicker, and they can all see each other's answers, right? And you say, well, the majority answer was A, and that's not correct. Discuss amongst yourself options B, C, or D. The chaos that erupts in the room when they're like, what do you mean A is not right? They can't even focus on discussing B, C, and D because they're so sure A is right. Or if you ask them to, you can be inspired by a concept inventory. Ask them to draw what they think is going on in solution on whiteboards, and then walk around and have a gallery walk, or there's many different ways to do it in the classroom, to show those drawings. And you say, did you all agree? Like, this is fascinating. And when you do it with a group of majors, did you all have the same drawing? No. Do you think you should? Yeah, we're chemistry majors. We learned this last year. I don't even, how can we not know this? They recognize the face validity of these items as things they should know, but because they were never taught to think about the concepts underlying, in some cases, the calculations, or what's the mechanism for an SN2 reaction, right? So Maya's got a great paper about how students are trying to put the different intermediates and transition states along the curves of reaction coordinate diagram. And if there's an odd number, they run out because they don't know how to connect the symbols and the mechanism to the actual curve itself. And so those are great opportunities in the classroom to say, okay, I've created a need to know here. How are we going to work through this? Let's get the competing ideas out. Let's work through and honor each of them one at a time. But creating that need to know is not just for the teacher. It's really for the student, right? You've got to have some activity, some data for them to chew on where they go, you know, I don't actually know this as well as I think I do. And it's important to me to figure out what's wrong with my thinking and how to improve it.
So I would agree with that, you know, completely. You know, to me, the best use of a concept question is to really sit down and think through why the wrong answers are wrong, and get students to articulate that, and that, you know, that, and you know, so getting them to think outside their normal reflexive response.
I think we'd be really remiss. Vicente's on this call. We haven't heard from him, but your paper, Vicente, last year where you published about what happens when you ask students to predict what the wrong answer is in concept inventory, like, to me, that's just fascinating. That was just such an elegant study. And I thought that was a great use of that as a tool to get students to think through what the different distractors are.
Right, and you know, it's like, if you don't know why the wrong answers are wrong, you don't know anything. I mean, essentially, that's one of the key things. You know, you're talking about training people to think in a critical way, so they, you know, if you can't tell me why the wrong answers are wrong, you don't actually understand the answer.
Yeah.
So what are some of the challenges with using concept inventories in teaching?
Well, I'll just say I don't use them that much, because I already have done it on a number of classes, so I have an idea of what's going on, and I'm trying to incorporate those ideas already in the redesign of the course.
Yeah, so
I wouldn't use them for, you know, just to prove that the students had learned things. Okay, so that's not how I would use them.
All right, so again, I'll draw a distinction between a challenge for a teacher and a challenge for a student. We've talked about the challenges for teachers. You really shouldn't be teaching to these, even if you've tried and it's not been successful. That's really not what they're for. But for a student, there is tension between, do they respond how they really think about it, or do they respond with what they think the answer is that the teacher wants? And Zyleen's on this call, and she has some really interesting data in her instrument about quantum representations of electron structure of the atom, where in the interviews, the students were saying things like, we were showing them different representations of the helium atom and asking them to talk through this. And they started asking us, which one of these is right? Like, after the interview is over and the tape goes off, right? Is when the really sort of interesting thing happens in a clinical interview. And they wanted to know which one was right and why. And so we ended up asking at the end of the inventory on her research, we asked them, which one do you think is more accurate, and which one do you think your professor thinks is more accurate, right? Or which one's in your mind? And they will not answer the same thing for both questions. They have these just different mental models. And so one of the challenges with teaching is to create a classroom environment where I refer to it as the Vegas environment when I teach, right? What's said here stays here. Like, you can say things that you would be horrified if your research advisor heard you say, or that you're really, somebody will kick you out of the major. You won't be a pre-med anymore if it gets out of the room. It's really challenging to create that environment in the classroom so students can honestly tell you how they think about it, no judgment.
So I am going to propose that we actually kind of extend the question and answer space for our audience. So if you have questions that you want to ask in real life, go ahead and raise your hand and I will unmute you. And then we'll shift to addressing some of the questions that were written in the chat. David, I have you on again.
Okay. Mike, you indicated you did not think that a concept inventory was a good pre-post measure, pre and post for instructional effect. And I wonder if you could comment on whether or what type of thing might be such a good measure. And Stacey, I wonder if you could weigh in on that issue also. Can you use this concept inventory as a pre-post measure? And if not, is there something that one might design that would be better?
Well, I mean, I'm tempted to say that the answer is write a really good, difficult to grade exam question and let them try to answer it, you know, and see whether they can expand on what you need to do. We've been using the B-Socratic system that Melanie Cooper's group has been working on for a long time. And that allows us to, you know, draw a graph, explain what's going on. And so you're looking at open-ended. To me, it's like, can you talk about the system? Can you explain to me what concepts are used, what concepts are not? So they would be open-ended questions. Now, you know, biology is different I mean, every discipline is different. We're less quantitative. There are no number answers, right? You know, nobody could do that. Biology students, even molecular biology students, are not taught how to model, you know, multi-component systems with, you know, so, but that idea of giving questions that require the use of a number of different ideas, that would be my best. But again, you know, it's like, depends on what you want. If you're really trying to establish the validity of your instructional design and delivery, then you're talking about building a higher resolution instrument, which is going to take more time to decode. There's no multiple choice test that's going to tell you whether students deeply understand molecular movement.
Right. So if you use a concept inventory to surface your students' prior knowledge, and then your instruction is responsive to that, right? And then measuring it on the post side is really not going to, it's not going to lend any new insights to you. I would say, I think there are a couple, I've tried to encourage a couple colleagues to give it as a pre-post who are more skeptical, right? Like, give it as a pre to make sure you're sure the students don't know it before they get you, and then you do your best. Have at it with the number crunching and the iteration on problems, quantitative problems, and then you measure at the end and see that there's no change, right? So there is that limited context in which I think a pre-post can be useful. I see you put out in the chat about test retest. You know, traditional measurement literature would say that if you do the retest at about 3 weeks out, that anything that's been memorized has faded, and you're measuring what signal remains at about 3 weeks out. So we do a post kind of measurement when we're doing it with about a 3-week separation to see, to look at the stability of students' reasoning there. You're never going to get 5 9s, which an analytical chemist wants, but you know, we can get about a 0.8, which is pretty good for human behavior.
I mean, the only thing you could, I mean, if you really want to use it pre-post, all it tells you is whether you succeed. What, you know, it can tell you whether you completely failed. It can't tell you whether you succeeded, but it can tell you whether you completely failed. Okay, so I mean, I think not looking for the shortcut. I mean, remember, you know, to me, the standard for education is a Socratic interrogation. You know, why do you think that? You know, what's going on? That's the kind of thing you have to do if you really want to prove that people are getting it, and that's expensive.
Rania, you had a question?
Thank you so much. Mike, this was definitely a lot of insight because I was using them for pre-post, and so this was eye-opening to me, so thank you for that. The question that I have to ask you, I totally agree with you about the open-ended questions. That's the best way to really understand if students can articulate whether they understand something or not. Trust me, I've graded laboratory before, and it gets really, really interesting when you try to get to the bottom of it. But my question to you is, if I am introducing some sort of treatment to see if my introducing learning assistance has improved, you know, course grades, for the sake of time, how do I assess that? Because I don't have all the time in the world to give them open-ended questions, and they might not take it seriously because it is more of like a research tool that I'm using unless I make it for a grade. What other ways that I can look at time with this perspective?
Well, I'll say I'm not sure I have the magic answer. I think the answer actually is a sort of educational political one, is how much does the institution value student learning outcomes? How much do they matter? And this can be very different in different areas, right? So engineering tends to be more interested in whether people come out knowing what they're supposed to know than the standard academic arts and science type department. And so the question is, well, what resources are you given to evaluate student learning outcomes? Are that, you know, so is there, for example, in molecular biology, a end of instruction assessment? Well, the answer is in most places no. And it tells you that, you know, there's no real, I think it's a political question. I think you do your best you can that you're satisfied with. But unless the institution values that, and this is, I realize this is not an education research type question. This is a, what does the institution value? What resources are you being given to say, okay, so our curriculum is training students well or not, okay? And as opposed to, you know, a lot of assessments are designed to sort students rather than to evaluate their learning. So to me, that's the giant gorilla in the room, which many people don't want to deal with. So I say do the best you can so that you feel you can sleep at night.
So I'm going to throw us back to some questions about cognition that were posed in the chat. This one was from Elizabeth Day, who asks, thinking about the nature of knowledge, especially with respect to novices, how would you characterize conceptual understanding? And do you think about those concepts we are trying to measure as coherent and stable?
Stacey, do you want to go or do you want me to go?
I don't think about the concepts as coherent and stable across the life of an undergraduate. I think we tend to have benchmarks along the way, like what a student might know after the first year of a program, what they might know as a second year, what they might know in their third year, and by the time they graduate. But they're definitely not stable. It's kind of, as I already admitted that I get horrified in group meeting when I hear the data, right? So when you hear physical chemistry students trying to reason about colligative properties and you think they've had an extensive discussion of enthalpy and entropy and free energy and this should be a no-brainer, but there's no integration of those ideas with other things because their instruction and their assessment has reinforced this very fragmented knowledge structure for them. Yeah, these ideas are definitely not stable for the people that we tend to measure in our group. You know, if we went and talked to a different sample of people, I think we could explore the assumption that they might be stable, but there's a lot of fragments that come and go in the life of an undergraduate. And to go back to the question that Alina asked us that was provided, I think, when we were first organizing this about the resources framework, you know, what context do you ask them to do their reasoning in really does shape which of those resources they bring to bear.
And I would say they shouldn't be stable because you're trying to encourage the growth of ideas that are not commonsensical, that are almost always counterintuitive, right? The way atoms, I mean, the idea of an atom is not something that's overt, right? And so you're trying to build a coherent conceptual framework through the course of a curriculum, which is part of the reason Stacey is shocked that people don't have one at the end, because in part there's no real incentive to build that, right? To integrate courses in a way that build to that idea. And so, you know, I think you are trying to get people, it's almost like a sport. I've been thinking about a lot of this. It's like you're coaching the students up to come to learn how to play the game so that they, you know, abandon certain ideas, they embrace other ones, they see the value of those ideas. And the value of a good concept is it's applicable everywhere. If I'm talking about a biological system, everything is a molecular machine. Everything is built on interactions. Specificity is built on interactions. I can predict what happens if I change anything in a plausible way, right? I don't know if it's right. I have to do the experiment, You know, if I change the binding site on DNA of a protein, I don't know exactly what's going to happen, but I can guess, so I can use it over and over and over again. So you're building this idea that I'm teaching things that are universally relevant, and that if you care about a specific problem, you can unravel it using these ideas. That's the mark of an educated person, who can recognize the absurdity of certain ideas, okay, and can quickly sort of navigate their way. Not that they know the right answer, but they can recognize something that's nonsense, right? And so I'm very much, I don't believe that ideas stay the same. They shouldn't stay the same. You're building ideas that don't make any sense to the normal person because they're, you know, they're counterintuitive. Okay, you know, why carbon makes 4 bonds, you know, why 2 electrons can't be in the same state in an atom. I mean, who would guess, right? So you're trying to build something. And the whole point of the course structure, the curricular structure, is to leave the student with the tools needed to unravel any new problem, as opposed to learning the answers to a bunch of questions. So, I mean, that's how I would think of it. Now, unfortunately, the sort of institutional incentives to get departments to, you know, come together and come to like a consensus about what's really important, that generally doesn't exist. And it's even worse, for example, in biology, because biology is so huge in the sense of every organism is its own biological problem, that you know, you don't see that as being a driver. But to me, that's the driver, is to get people to be able to take a biological problem and say, okay, I can break this down into things that don't make sense.
So I'm going to share one more question that I found very interesting. Do you know of any research that links concept inventory results to frameworks like Posner's theory of conceptual change? And if not, do you think there's space to relate those two?
I defer to Stacey on this, since I haven't heard of Posner before.
Well, George Posner was a professor of curriculum instruction at Cornell, and I took both his courses on curriculum development and curriculum analysis. So he's more than just a name to me. He's an actual person.
Experience.
That being said, his papers with Ken Strike, there's 2 classic ones that you should read if you haven't, are early ideas on how conceptual change happens, and not, they've been replaced by more developed models. But it's a really good place to start to get your head around what it takes to encounter and create conditions for changing students' thinking, or faculty thinking, if the conceptual change you need is about what is teaching and learning. Just as an example. Can you tell I had faculty meeting today? Yeah. Okay, so now I've left myself into forgetting the question. Oh, is there research that connects them? That's the question. I am not aware of anything that connects directly to Posner and Strike's model of conceptual change with concept inventories. But if somebody is, I'd love to know about it. So put it in the chat.
However, I would like to extend the question. Do you think that using concept inventories, one could decide whether a framework that is more based on theory or knowledge in pieces is the best to describe conceptual change? So do you think that concept inventories are good tools to be able to decide between theoretical frameworks?
Thanks for reframing that, Vicente. That was helpful. I think there's just severe limitations to that, because the context in which I can only speak about the methods we use in our group to do our clinical interviews. And so when we do those interviews, we've picked a particular demonstration or set of representations because we have some ideas from the literature about what might be problematic, or put another way, what might be spicy and interesting to get students to talk with us about. But it's not, by its very design, the fact that we've picked something means we're not picking something else. And so, you know, when we say we have a redox concept inventory, it's not all of redox. by any stretch of the imagination. It's just a slice of it. And so I think the amount of data you could get from any one concept inventory would be very limiting in order to explore the applicability of knowledge in pieces or theory or any other thing like that.
And I guess I would say it's sort of it's a more pragmatic approach. I wouldn't worry. As a biologist, I barely understand how any biological system functions, much less the human brain. And so, you know, you're looking for evidence that something works. You know, and I think it's possible you need to identify the key components, but I don't think the theoretical approach helps all that much. I think it's like, you know, what worked, what didn't in a particular case, and what evidence do you use to say it worked? You know, can you articulate what it means to really get this? You know, and our students accessing it in different, you know, in sort of homologous or analogous contexts. You shouldn't use the word homologous. Analogous contexts.
Yeah. Can I put out a call for any more questions from our audience? Oh. All right, David, you're good to go.
One of the things we've done, I and other people in PER, we've looked at the consistency of student responses as a measure. Consistency of, for instance, the consistency with which they choose a group of distractors. And one of the findings, something that I did, was to look pre and post at how students, at a set of questions that were related to each other, and the observation, and pre and post. And so the observation was that the students, by the one marker was that the students were less consistent in their collection of incorrect responses. So before, as a pre-marker, they would choose several things consistently that incorrect, you know, distractors that were related to each other. And afterwards, although they would still choose distractors, they would be less consistent. And so I wonder if you have considered using that sort of consistency or lack of it as a possible marker of something, either of learning or of, well, something associated with learning. Is that something you've tried to?
It sounds like a marker of confusion. You know, so I mean, I think it's a good marker of, you know, people not knowing, you know, they're confused, and that's an important thing to recognize.
Yeah, so I think, you know, this goes back to the question Jack asked about how do we what would I propose for reliability and validity? And I just think it's really, really hard to tackle that reliability question. So if we're gonna be looking at consistencies with distractors for test, retest, or pre-post, or, you know, more than one administration of the same instrument to the same group of human beings, it's hard for me to draw any conclusions about consistency or inconsistency of their responses without having characterized the teaching and assessment that went on in between me coming in and measuring at time 1 and at time 2. And in our research, we've intentionally not gone in to try to characterize the instruction that's gone on, right? So there's a big black box that's happening there that you don't know whether it's the conclusion, the easier conclusion or the surface conclusion might be, oh, this is random. See, we can't really put stock in what students say. They're just randomly picking an answer. But I don't know that that's true because I don't know what instruction and feedback loop they got about formative and summative assessment from their teacher that may have made them change their answer.
Yeah, this speaks to a question in the chat from Elizabeth Day, and I think that's exactly right. They may not be confused. They may just now have embraced another explanation. And again, what's going on in the context of instruction may be the driver.
Melanie, you want to ask our last question?
I do, yes. Hello.
Hello, Melanie.
I just couldn't let that drop. So, sorry. So I feel like the problem is with concept inventories as a kind of to situate the theory of cognition and conceptual change is the wrong question, because you can't, as Stacey said, what you've got is a very, very limited situation where you've tightly controlled the question and you have tightly controlled the answers. And I think if you want to look to see whether students' ideas are stable or not, you have to be more flexible about it. So if you interview them and you slightly change the prompt and you elicit completely different resources, what that tells you is that their concepts are not stable. And I think that that's what people are finding now, is that in many instances, the students' ideas are not stable. They're dependent on the prompt. They're dependent on how the question is asked, as to what resources are elicited. Oh my God, that's not a question, is it? I'm horrible. So what do you think about that?
What do we think about Melanie, Mike?
Well, the session is coming to an end.
That's correct.
And, I have to pick up Indian food for my family.
I think you make an excellent point, Dr. Cooper.
Well, I mean, I think that's exactly right. And so what you're learning is that their commitment to any particular framing is extremely labile, right? Which tells you a lot in a way. I mean, they're searching for answers. I think Valerie Otero would say they're swooshing for things, or there's another word, but they're reaching out, trying to find something that they can pull back in, which tells you that you're not dealing with a religious preference for something. You're dealing with they're confused, right? They have a lot of ideas running in their head. None of them are getting real traction. None of them are compelling. And at the end of the day, that's not what an expert would do, right? An expert would say, don't worry about this. This is focus on that, right? And so the fact that their response changes so dramatically depending on the prompt tells you that the underlying thought is fragile or ephemeral or ambiguous. I mean, it's easily like Alice in Wonderland. They could think 6 things at the same time.
Yeah, and they do. So when we do our clinical interviews, we choose representations or contexts in which we're pretty sure they're going to come up with conflicting ideas like that. So that started way back with Kim Linenberger and our research on enzyme substrates. We give them one representation, they say one thing. We give them another, they say completely contradictory. We saw it most recently with Tim Abel and asking students to literally hold beakers while salts were dissolving. Of course, we give them the exothermic one first and it gets hot. So we get the classic, oh, the bonds broke and the energy flew out, right? Which we blame on you, biologist Mike. Okay, and then you give them one a couple minutes later that's endothermic. Some of them will tell you the same answer. And when you say, well, then why didn't it get warm? They're so clung to that one idea, they can't offer an explanation. Some of them will turn around the explanation to match the physical sensation. And when you point out the contradicting ideas, it doesn't trouble them that they've contradicted. So students can hold they can hold one idea and stick to it no matter what. Even in the face of contradictory evidence, they can hold contradictory ideas and not be troubled by it at all, because it's like, well, sometimes chemicals do this and sometimes chemicals do that. And it doesn't bother them that there's no underlying consistent concept that should have explanatory power, no matter what the particular sample is or system is that we're looking at. And that's really interesting to explore in those interviews, is what do students do when confronted with evidence that contradicts what they just said?
They're not taking their own ideas seriously. So the reality is you just learned that they don't take their ideas being very serious.
Well, I wouldn't say they don't take them seriously. I would say they've never been in an instructional setting that's actually asked them to do that before. They've taken on the role of the teacher, the book says it, and I repeat it back. They've never had to explain something that appears contradictory on the surface.
Let's not forget DeSessa's early 1980s work, which on p-prims, which really is the foundation of the resources idea that so many people are talking about right now in this conversation, where he was really looking at what are the foundational pinpoints that might lead to people to say contextually dependent things that they ended up saying. So closer is more, bigger is more. And that's where some of those ideas about the sun and the earth and the seasons come from. And so like a lot of those things that appear to us to be inconsistent are deeply consistent to the student who's going on a more foundational primitive idea of closer is more, bigger is better. And I think that's why the physics education research community at an early point started to think more in terms of resources rather than misconceptions or big, gigantic, chunky conceptions, and more in terms of what are the little teensy weensy things that are coming out that in this context that may not be consistent across concepts. What do you think of that? That's my question.
No, I totally agree. The problem is science is built of ideas that are counterintuitive. And that's the hardest thing to do. Okay? And you have to recognize, these underlying ideas, but science is foundationally counterintuitive. And that's the deal, right? And so that's what makes it difficult.
And on that note, I want to thank you all discussants so much for sharing with us and for the wonderful questions from the audience. Thank you. And we will have this recording posted and share information for how you all can view it.